Hello, I've had a question in Unit 2 for the 3U Physics, question number 12. Question number 12 states the object moves forward from the origin at a constant velocity for 10 seconds and then stands still for 10 seconds. What I want to do is I want to take a look at, let's add on another two graphs here so I can make a comparison here. So the first one's going to be displacement time, and then I'm going to add on an acceleration time graph just so you can see or make that comparison. So that's acceleration time. Okay, so when we're talking about moving away, okay, or the object moves toward the origin at a constant velocity, for a displacement time graph, our origin is really that they're referring to is the x-axis. All right, they can't actually physically move to the origin in that direction because they would be going backwards in time. So when they talk about moving toward the origin, they really mean moving back toward their starting point or the reference point. And for this blank graph, we would assume our x-axis is our origin. Okay, it's where you started from. Now on a dt graph, a constant velocity is shown by two different types of lines. Okay, we also have, I guess, a third one as well. So we have away, toward, and still, or standing still. So those are your three options. So I'm going to just give you a dt graph because it'll help make sense on what the vt is representing. So if we're moving toward the origin at constant velocity, that means we were starting somewhere away from home. So if we call this our home, let's call this school. So you walked home at a constant pace. All right, so that represents moving toward origin. All right, at a constant pace. So I can put that in there as well, at a constant pace. Now, the question really is about velocity. So how would you describe your velocity? Well, because we're using the word constant, it means that your velocity is constant. So if you look at your dt graph, the slope of this line that I just drew is constant. Doesn't matter where you take your slope. Slope will be the same at any point along the line. What type of slope is it? Well, it turns out to be a negative slope. So for the first 10 seconds of this particular graph, we're going to have a constant velocity, and it's going to be a negative velocity. So it's going to look like that. So there's our negative velocity. Doesn't matter at what time we're looking at. So if I look at 1 or 5, the y value is the exact same, which makes it a constant velocity. All right. And then stand still for 10 seconds. So if we go back to the distance time graph, well, if we say we get home, you're really not moving toward or away home if you're there. So in a dt graph, your standing still is a horizontal line located anywhere. But at that point, if you're not moving, your velocity is 0. So for the next 10 seconds, your velocity is on the x-axis because it's going to have a velocity of 0. So that's what it would look like with that particular graph. All right. Acceleration, then I threw that in there because we're talking about constant velocity. Acceleration would be 0 for this entire trip. All right, because you're not changing your velocity throughout. So hopefully that makes sense. So I added in 13 just in case people want a comparison. It wasn't part of the original question asked, but I'll put it in anyway. So the object moves away from the origin. So again, many people have seemed to be able to kind of make sense of this one. It's that moving toward the origin where a lot of people kind of get tripped up. So if we're moving away, again, when they refer to the origin, it's really where did you originate from, where did you start from? So in this case, we're moving away from the origin. Now you could start there, or you could start there. In either case, you're moving away from your reference line or where you originated from. So that x-axis represents your home. Okay, to put it in practical terms, and here you are, now you're walking to school. All right, so you're going to school, constant rate, usually you walk at a constant pace. Some people might skip and hop and change, but for the most part, we walk at a constant pace. and then you reverse directions and go back to the origin. So you forgot your lunch, and you return home. So that's what it would look like. So you get to one point, and you would say, oh gosh, golly gee, I forgot lunch. At this point, you pivot and immediately make your way back home in order to get that lunch. So that first stage is a constant pace away from the origin or home. The second stage is going back to home. All right, in that previous question, number 12, we're taking it as we're starting at school, so that's why we didn't have to move away from the origin. So we have a positive slope and a negative slope. So positive velocity for the first 10 seconds will look like this, and then all of a sudden we switch to a negative velocity because we're heading home. All right, and it all comes down to slope from your dt graph. All right, and again, in this case, because we're not changing our velocity in those time frames, acceleration in both cases would in fact be 0. Hopefully that clarifies the questions you had. If you had anything else that you want specifically answered, let me know, and I'll help you out.